In the previous one, you should have done the log rules, those log rules. So this section is about solving equations and using logarithms. So different methods. Okay, so I'll go through 2 examples to begin with. Okay, so the first one, 3 to the x equals 20. 3 is the base. So number 3 is the base. Okay, so this is an exponential equation. So you can convert that into a log equation just by the definition of a logarithm. So using the definition of a logarithm, you can say log base 3 of the number is equal to x. So that solves the equation straight away. Okay, so remember, on the calculator you have this function log, where you can enter the 3 and the 20. So if you look for the calculator function log, where you can enter the base 3 and the number 20, it will give you the value 2.727. 72, if they want it to 3dp. Okay, next one. Okay, so the base again. 5 to the power of 4x minus 1 equals 61. So the base is 5. So remember the definition of a logarithm. If you've got a equals b to the c, then logarithm of the base of the number. So that's all I'm using. So in this case, log base 5 of the number 61 is equal to 4x minus 1. Okay, so you can work this out on the calculator, and then you just solve it. So x will be equal to 1 plus log base 5, 61, all divided by 4. Type that into the calculator, and that will give you your answer as a decimal. Get it on the calculator, 3dp. Any questions on that one? Okay, next. Okay, this is the trickier one, the quadratic one, equation. Okay, so what you need to do, you got 5 to the 2x and you got a 5x. This term 5 to the 2x, you can rewrite as 5 to the x squared. Power to a power will give you 2x minus 12 times 5 to the x. Okay, so you can think of it as a quadratic in disguise. So if you want, you can put y equal to 5 to the x. So you can see that it's a quadratic, like y squared minus 12y plus 20 equal to 0. Okay, so you solve the quadratic first of all to find y, then you go back and find out what x is. Okay, so this quadratic can be factorized as y minus 10, y minus 2 equal to 0. So you get 2 solutions for y, but you haven't finished yet. The equation says you've got to solve the equation back in terms of x. So you've got to find out what x is. So you've got 2 cases. So first case, 5 to the x equals 10. And the second case, 5 to the x equals 2. Okay, so these can be solved in the same way as the previous examples. So x is going to be log base 5 of 10. You work it out on the calculator function. You get 1.43. Run 3 sig fig. This one, x equals log base 5 of 2. And stick it into the calculator, 0.431. 3 sig fig. Okay, any questions on that? Okay, yeah, there's one more before the exercise. Okay, this is a tricky one. Okay, there's two ways you can do this. Okay, I'll show you the book way, then I'll show you another way. Okay, so you've got different bases, so you can't solve it directly. So, okay, so what they do in the book, you can apply logs on both sides. You log both sides. You're allowed to do that. Okay, so you can use any base when you log both sides, but book, well, you might as well just use log base 10. So log by itself just means log base 10. So you on the calculator, you should have like a log button somewhere. Can you find it? Must be somewhere on the calculator. Okay, so you begin by logging both sides. Okay, so you go like log 3 to the x, log 2 to the x plus 1. Okay, so I'm assuming it's base 10. Then using the laws of logarithms, so the, where is it? The third law of logarithms was that log x to the n, the power comes to the front. That was the third law for logs. So you can apply that law to this case on both sides. So the left-hand side will become x log 3. Right-hand side, the whole thing is the power. So all of it will come down. You put a bracket around it. Okay, so then you can just try and solve it. Just a linear equation. Okay, so you can expand the brackets. X log 2, 1 times log 2. Okay, so it's x log 2 plus log 2. Okay, then you just move the x terms together on one side. So move this to the side maybe. So you get, okay, and you can also factorize it. Like that. And then the final step, you can just divide. So you can evaluate it on the calculator now. So you need to do log 2 all over the bracket. Okay. Stick it into a calculator, and then you'll get your answer as a decimal. Okay, so that's one way you can do it. Okay, any questions on that? Any questions? How did you get from the line on top of the arrow to the one underneath the arrow? On top of the arrow, okay. I just move it to the left by subtraction. Okay. Okay, ready? I'll show you the second way to do that, the other method. Okay. The other method, let's see. Okay, other method. Okay, so what you can do, 3 to the x equals, separate 2 to the x plus 1 as 2 to the x multiplied by 2. Okay, so remember, you add the powers. This is like x to the 1. Okay, I can divide now, so I can say 3 to the x over 2 to the x equals 2. So the left-hand side, top and bottom have the same power. So I can rewrite this as 3 over 2, like that. Now I can solve it like I was doing before. So the base, this is 3 over 2 is my base. So I can now say log base 3 over 2, right, is 1.5, of the number 2 is equal to x. So I reckon that if you type that into the calculator, log 1.5, 2, I get the same answer. So that's a clever way to do it, if you like being clever. Okay, any questions? Okay, next bit. Page 326. 326. About natural logarithms. So on your calculator, you have this other function. Okay, so the way it works, ln of a value is defined as log base e of the value. Okay, so on the calculator, you have this ln function, ln key on the right. That's short for natural logarithms, natural log. Okay, so it just means log to the base e, and e is this number 2.71, etc., etc. Okay, so ln is natural logarithm, short for log base e. So you've seen before the graph of y equals e to the x is this exponential curve. It gets faster and faster. So that looks like the growth rate of the coronavirus, actually, exponential growth. It has an asymptote on the x-axis. If you do a graph of the natural logarithm function, so y equals ln x, log base e, okay, you'll find that it's a mirror image of e to the x in the line y equals x. So you have this line y equals x in the middle. So if you reflect y equals e to the x in the line y equals x, you obtain the natural logarithm graph. The y-intercept is 1, and logarithm of 1 is 0. Okay, so the log graph has a vertical asymptote. Gets closer and closer to the y-axis, but doesn't touch. Special properties. Okay, so so the exponential and ln, these are inverse functions. They're called inverse functions. So they do like the opposite thing. So for example, if you were to calculate e to the power of ln, so pick a number 7, they would cancel out. So if you typed it into the calculator, you would just end up with 7. Because they're inverse functions. They do the opposite. And it's the same thing the other way around. If you were to type in ln, then type in, say, e to some number, ln and e, because they're inverses, they will cancel out, and you'll just get the number 6. Is that okay? The examples are basically about solving equations again, using this idea. On the first one, e to the x equals 5, the simplest way to solve it, ln both sides. So you can take natural logarithms on both sides. Natural log on the right hand side. They want the answer as an exact value, exact form. So first of all, ln and e, they cancel out because these are inverse functions. So you just get x by itself. So you get the answer straight away. Okay. The question says leave your answer in exact form. So they don't want some long decimal. Just leave your answer as ln 5. So that would be the answer. X equals ln 5. Okay. Same thing with this one. Solve the equation ln x equals 3. So you can use the inverse property to solve the equation. Okay, so you can e both sides. Thinking about e, so the left-hand side becomes the power of ln. Got to have a power. Then you e the right-hand side, so the 3 becomes a power, like that. Okay, so because these are inverse functions, e and ln, they cancel out. So you just get, on the left-hand side, you just get x equals e cubed. So again, you don't need to work it out as a long decimal, because it says exact form. So that's the exact solution to the equation, x equals e cubed. How's that? Any questions? Okay, so it's the same kind of idea. Okay, so this one, you've got exponential equation. So you do what you did like in the first example, you ln both sides. You want to cancel out the exponential function. So to cancel out the exponential, to cancel out the expression, you ln both sides. You go ln of the left-hand side equals ln of the right-hand side. These are inverse functions, they cancel out. So you must get the power 2x plus 3. Okay, and it says give your answer in exact form. Exact form means not a long decimal. So you just solve it. So you get ln 7, take away 3, or divide by 2. So that's okay. So you don't need to work out as a long decimal, it says exact form. So that would be your answer. Okay. Any questions on that one? Next one. Okay. Here you need to watch out. Okay, you can't eat anything yet. You can't. Okay, so you can't do this. If you do this, I mean, this is just bad. Okay, that's bad. You can't just do that, I'm afraid. Okay, so you need to isolate the ln term first. Okay, so you need to do some rearranging first. So you can write that as 2 ln x, take away 1 to get 4. So again, you can't e both sides yet because you've got the 2. So you need to divide by 2. So you get ln x, 4 over 2 is 2. Okay. Once you've isolated ln x by itself, then you can e both sides. So to cancel out ln, okay, so you've got to have the ln by itself, then you e both sides. Inverse functions, they cancel out, so you just get x equals e squared. And that is your exact solution. How's that? Why is it divided by 3? Have a look. Oh god, yeah, Aaron. That should be a 2. The last one looks a bit tricky. Okay, so again, this is like a quadratic in disguise. So you can begin by saying, okay, so what you mustn't do, you can't just ln it. So if you do ln, if you do this, I'm afraid that is just bad. You just ln everything, that's just bad algebra. So you can't just do that, I'm afraid. Okay, you need to recognize it as a quadratic in disguise. So you can think of it as e to the x squared plus 5e to the x, okay, minus 14 equal to 0. Okay, if you want, you can make the substitution y equals e to the x. Then you can replace that to get a quadratic, y squared plus 5y minus 14 equal to 0. So that can be factorized as y plus 7, y minus 2. So that gives you 2 solutions for y. And then you've got to find out the corresponding values for x. Okay, so the substitution was y equals ex. So the two cases are, and e to the x equals 2. So this one is easy. You just ln both sides. So you get x equals ln 2. Okay, this one, if you try to do x equals ln minus 7, you'll get a problem. Because you can't do logs of a negative value. So that would be invalid. So the equation only has one solution. So remember, if you think about the graph of e to the x, e to the x is always positive, so it cannot be negative. Okay, so you only get one solution from e to the x equals 2. Any questions?